Remember how I said if genes are linked, right? That means genes are found on the same chromosomes, and that we make two, right? So like if this was little a, this was big B, this is big A, this is big B, and these two crossed over, right? And then big A ended up here, little a ended up here. That we're gonna see big A, big B, little b, big A, little b, little a, big B. So most of the time, okay, just to reiterate you guys, most of the time, it stays like this, and you don't see any kind of crossing over occur, but sometimes it happens. These two switch positions, and you get crossing over, which means sometimes you get a little a, big B gamete, and sometimes you get a big A, little b gamete, and these guys are called my recombinants. And that was the lesson I taught you last time. Now, what we're going to do today is I'm going to show you. Remember how I said we see like 200 of these and 200 of these and less of these? Okay, and the reason why we see more of these and less of these is because, again, right, big A, big B, little b. If little a ends up here and big A ends up here, little b and big B, right, that we get smaller numbers of these because of recombination, right? Because crossing over occurred. And I see about equal, if I get equal little a, big B, and equal big A, little b. These guys are produced in equal proportions, and these guys are also produced in equal proportions, right? 1 to 1 here, 1 to 1 here. Anyways, there's a calculation that comes with this, and it's called recombination frequency. Woo! Recombination frequency. And it's like the number of recombinants divided by the total number of offsprings. Hopefully you guys are happy, healthy people right now. Times 100%. All right, stay healthy, guys. We will get through this. Okay? This too will pass. Just got to get through it. All right, anyways, so the number of recombinants. How many recombinants did we have? Well, these guys are my recombinants. I have 10 here and 10 here. So the number of recombinants is 10 plus 10 divided by the total number of offspring. So 200 plus 200 plus 10 plus 10. So we add the total number of offsprings. 200 plus 200 is 400, 410, 420. So we're going to get that. So we're going to get 20 divided by 420 times 100%, right? So here is our handy dandy calculator. Okay, so it goes 20 divided by 420 times 100. Okay, so the answer is 4.8%. See that? 4.8%. That's my recombination frequency. So that just means I see recombination occurring 4.8% of the time. So 4.8% of the time, I see crossing over occur in my offsprings. 4.8% of the time. That's what that number means. But that number also means, okay, that, erase this. I'm going to draw a line here, and this line represents a chromosome. Okay, so like, imagine, here's your chromosome, and this is the line. This represents the same thing. And basically, it's telling you that genes A and B are 4.8, and we call it map units apart. Okay? So the crossing over percentage I get actually tells me how far apart these two genes are on a chromosome. Okay, but we use a line. So instead of using and drawing a chromosome, I draw a line. The line represents the chromosome, and I say these two are 4.8, and it's map units apart. Okay, so that is why we need to calculate this crossing over percentage, right? Why we needed to do, hey, I had 20 kids divided by 420. This percent crossed over. That's how far apart these two genes are. And remember, I think gene A was like, I don't know, hair color. And gene B was like, I don't know, eye color. So it means hair color and eye color are 4.8 map units apart. And that's what that means. Now they're going to ask you to draw a chromosome map. So like they're going to say, hey, draw a chromosome map. And they're going to be like, hey, if genes A and B are 6 map units apart and genes C and D are 10 map units apart, how far are C and A? Right? So, and then we're going to say B and C are 10 map units apart. Actually, we're just going to say C and B. So if I have A and B 6 map units, and A and B 6 map units, C and B 10 map units, what's the distance between C and A? So basically, I then draw the chromosome map. And I'm like, okay, A and B, these guys are 6 map units apart. And C and B are 10 map units apart. How far are A and C? Oh, well, that's the total here, 16 map units. And I say the answer is 16 map units. All right, so I gave you a really easy question on mapping, right? Where they give you this kind of information and you say, okay, well, A and B are 6, B and C are 10, right? So the distance between A and B was 6 map units. The distance between C and B was 10 map units. Therefore, it's totally possible that the distance between A and B is 16 map units, right? That's how this kind of works, right? So I'm going to give you one that is off a diploma exam. So basically you have genes 1 and 4, 1 and 3. You have genes 2 and 3, 2 and 4, and 3 and 4, right? So these are the genes, okay? So there are 4 genes. And genes 1 and 4, 25.9%, that's their crossover frequency, which is the same as how far are they apart. This one is 18.8. This one's 19.9. This is 12.8. This is 7.1. And basically, what is the crossing over percentage between genes 1 and 2? That's the question. Okay, so they're giving you all this information. Okay, so you know that you have 4 genes. 1, 2, 3, 4. Right? And they're telling you that genes 1 and 4 are 25.9%. So they're saying genes 1 and 4 are 25.9 map units, right? And they're saying that genes 1 and 3 are 18.8. So here's 1 and 3. And between 1 and 3, right, they're saying this is 18.8. So this is gene 1, 2, 3, and 4. And they're saying genes 2 and 3 are 19.9. Okay, well, all of a sudden, if genes 1 and 3 are 18.8 and 2 and 3 are 19.9, that don't make any sense. That makes no sense. because 1 and 4 are 25.9. This is 18.8 between 1 and 3. In order for this to equal 25.9, 3 and 4 have to be, hold on a second guys, 25.9 minus 18.8, 7.1 map units, 3 and 4, right? Which, it works here, but how is it possible that the distance between 2 and 3 is 19.9? 18.8 plus 19.9 is way more than 25.9. So it can't be 1, 2, 3, 4. That is not the order of the genes on the chromosome. It makes no sense. So I gotta do it again, right? I gotta make sure the numbers match. Okay? So the answer is 1, 3, 4, 2. That's the order of the genes on the gene map. Why? Why? Well, take a look. What's the distance between genes 1 and 3? They are 18.8. What's the distance between genes 1 and 4? Gene 1 and 4 is 25.9, which means the distance between 3 and 4 has to be 7.1. Okay, 18.8 plus 7.1 is 25.1. Guess what? That works, right? And then the distance between 2 and 4 is 12.8, right? So therefore, can we calculate the distance between 1 and 2? Okay, so that means we need to calculate the distance between 1 and 2. Okay, well, between 1 and 4 is 25.9. Between 4 and 2 is 12.8. 25.9 plus 12.8. Hold on a second, guys. 25.9. 12.8 means that the total gene distance between the two is 38.7. And that is correct. See? So the answer is just not like 1, 2, 3, 4. You got to kind of work this out and make sure the numbers match to get the correct answer, right? So that is a diploma question. I'll give you one more. And then you guys, you know that workbook I gave you? That yellow one with all the gene practice problems? There's some like really tough problems on gene mapping. There's one particularly tough one with like 9 genes. You guys, if you could do that, you're like genius, okay? Genius level. Okay, anyways, genes 1 and 3. So here we go. Genes 1 and 3. Genes 2 and 3. 2 and 4. And 3 and 4. And the distance is 13.0, 24.3, 8.2, and 16.1. And they ask you, what is the distance between genes 1 and 4? What's the distance between genes 1 and 4? Alrighty then, so what do I do? I make my line, which represents my chromosome. And I'm trying to figure out, okay, let's try it. 1, 2, 3, 4, does that work? Okay, let's see. Well, it says the distance between 1 and 3 is 13.0. But the distance between 2 and 3 is 24. That makes no sense. 24.3. The total distance between 1 and 3 should be 13, so there's no way that could be 24.3. That makes no sense. See what I'm talking about? So then, I already figured out the answer. It was 2, 4.